Peggle! Welcome to our project on internal clocks by Josh Hanklin, Caleb Matthias, Jacob Smith, and Darian Toll. Our central question for this experiment is whether internal clocks are affected by audio and gender.
So for the design of this experiment, we chose participants specifically from the MakerHub space, and we would tell them instructions in one of the meeting rooms in the MakerHub space with us proctoring it. So the instructions that we told them was to look at the wall, and we use the same wall for every person, and then we would ask them to tell us when they thought it has been 1 minute, 2 minutes, and then 3 minutes of time had elapsed, and we would be timing with the stopwatch. So that was the main design of the experiment.
So this is a mock trial of the actual experiment we ran, except we obviously didn't include this data point. So first we explained the instructions.
1 minute, 2 minutes, and 3 minutes had elapsed, and then that'll be all.
Then we waited for them to say 1 minute had passed.
Okay, 1 minute, right?
Then 2 minutes,
2 minutes,
then 3 minutes.
3 minutes.
After that, I showed them their time, and then that was it.
3 minutes, 25 hundredths of a second.
Nice.
Yeah, good job.
Sick.
And then for other things about the experiment, we chose the MakerHub space because there were plenty of people to choose from. People were constantly coming in and out, and we were able to choose the most random selection of people for data points. For the duration, we chose 1, 2, and 3 minutes just for sufficient data for each person. So we were able to get 3 different data points for each separate person. For the sound, we used white noise and classical music, and we used this to compare random sound against music. And we specifically chose these just because the white noise, it's something to kind of muffle the background noise, and then the classical music, we just chose a instrumental song to also be playing in the background to muffle the background noise, and we saw if that changed anything in the data. And then for the wall, we just had that as a control for a visual stimulus.
So on this slide, we show how we used our 2K factorial test, with the females being the low, and then the males being the high, and then music being the low, and white noise being the high. The numbers listed are the average difference from a minute of time elapsed for each scenario. And the negative number in the bottom left just means that on average they were that much under a minute. But for our calculations, we just care about the absolute value. So from this, we can use the eyeball test, which doesn't have statistical significance, but it would appear that females are closer on the time estimates than the males. And with music, people were closer on the time estimates than with white noise. So to find the gender effect, we took the average male with white noise and the male with music average and subtracted from that the average of the female white noise average plus the female music average. And then we took that to get our gender effect. Similar calculations were done to find the sound effect and then the interaction effect. For doing these, we also considered outliers. And we decided that technically there were a few outliers when we ran the outlier test, but because all the conditions were the same during those tests and the other tests, we left them in because they felt like valid data points. They're probably just outliers because of our relatively small amount of samples. And here's a summary table of all the numbers I just mentioned.
All right, so this data table shows the difference between the average elapsed time for the category minus the true elapsed time, 1 minute. So that means that for the values that you're looking at, their actual average elapsed time would be 1 minute longer. But I show you this because we use it for our ANOVA test. Our null hypothesis for the ANOVA test is that there's no difference between any of these 4 means, and the alternative hypothesis is that there is a difference between one or more of these means. And we'll be using a standard alpha level of 0.05. So after inserting all the data into the trusty TI, we ran the test and we found that there's a 0.398 p-value. So that is not statistically significant. So we failed to reject the null hypothesis. But then after that, we realized, well, we just looked over 4 different data sets very quickly. Why don't we get a little more granular. So we decided to run some 2-sample t-tests in order to get a clearer picture of what was going on with the data between all the different variables. And our null hypothesis for that, just in a general form, because we performed it on many different means, is that there's no difference between X mean and Y mean, and the alternative hypothesis is that, yeah, there is a difference between the mean of X and the mean of Y. And we used an alpha of 0.05. So again, using the trusty TI, we ran 6 different 2-sample t-tests, which were unpooled, and we said that the means were not the same. And we found that there were no significant p-values. Though we do see that the male versus female was the closest, which is interesting because that reflects from our DOE square table, which kind of showed that females did a little bit better than males. So even though we didn't prove anything, this is good data because it quantitatively describes what we qualitatively saw with the DOE.
The results of our test failed to reject all of our null hypotheses, which means that instead we conclude that there is no significant difference in the accuracy of one's internal clock due to gender or sound.
Thank you so much for playing my game.